Assalamu alaikum. Hope you're all good. So today's topic is about power series. Up till now, we have primarily solved linear differential equations of order 2 or higher order when the equation had constant coefficients, right? So in application, higher order linear equations with variable coefficients are just as important as differential equations with constant coefficients. But even a simple linear second order differential equation with variable coefficients such as in a differential equation such as y double derivative plus x y equals to 0. This obviously you can see that this is homogeneous differential equation, it's of second order and the coefficients are variable, right? So this differential equation, upon solving, we can go for the characteristic equation method, like we can write it as m square plus x equals to 0. But since the coefficients are variable over here, so we cannot solve for m exactly. So these type of differential equations, they possess solutions that are non-elementary, right? They do not possess solutions that are elementary functions. But the good thing is that we can still find two linearly independent solutions of this differential equation. We can find two linearly independent solutions for this differential equation, but they can be they will be in the form of infinite series. They won't be a typical function, but they will be in some kind of a series. So let's just have a review on what power series is basically. So and then we will consider how to solve a differential equation, a homogeneous differential equation with variable coefficients with the help of power series. Like, we need to see how power series solutions came into form, right? So let's start by reviewing some things about power series, right? So the first things first, recall that a power series is something of is basically sum of infinite series, infinite terms, sorry. So we can write it as, if we are writing it as this, right? This just means the summation. This sign means the summation, and this is basically the summation index. This n, this is the summation index, right? And we know that this n is starting from 0 and ending at, like, it's going on and on and on, it's infinite. So it's from 0 to infinity, and the series looks like this, like Cn, which is a constant term, and the variable term over here is x minus a whole power n, right? So if we try to open this up, if we try to open up this series, we can see how we can open it. Let's just we're just gonna put in different variations of n over here in order to open this, right? So n equals to 0, if we put n equals to 0, so हमारे पास यहाँ पे आ जाएगा c naught x minus a whole power 0, which can be equal to c naught because something power 0 is 1. Then if we put n equals to 1, the second term of the series will appear, and that will be c1 x minus a whole power 1. And similarly going on and on. If we put in n equals to 2, the third term will appear, that will be c3 x minus a whole power cube, and up to so on, right? So this is infinite series, so the terms will go on and on as we put in different variations of n, right? So okay, and this will, upon simplification, this will look like this, plus c3 x minus a whole, this is 1, this is sorry 2, right? And so on. Okay, so just look at this series. This is basically power series. This whole thing is basically called power series. Okay, and specifically this is since we have this because of this x minus a thing, this is called power series, which is centered at x equals to a, right? So if I write a series, a summation, n equals to 1 to infinity 2 power n minus 1 into x power n, so this is called a power series. I'm writing a short form of power series as PS. So this is called power series centered at x equals to 0, because this is just x over here, so it can be written as x minus 0 whole power n, right? It's the same thing. So so this is just an extra knowledge, just information about power series, how generally power series is written, and what is the center point. That means if this is written like this, so we can say that power series is centered at this point, and if it's like just x to the power n, so we can say that this is power series centered at x equals to 0, right? So we are just going to deal with the questions, we're just going to deal with power series which are centered at x equals to 0, right? So let's just see how we can add how we can do some arithmetic operations with series. How we can add, or how we can subtract, or similarly how we can take derivatives of different series. Let's just see how we can do that. So in order to see that, let's start with the addition or subtraction. You can let's see what's the criteria for addition or subtracting, adding or subtracting two or more power series. Let's see. Okay, so let's say that I need to add series n equals to 1 to infinity 2 power n cn x power n minus 1 and plus n equals to 0 to infinity 6 cn x power n plus 1. Okay, so these are the two different series. You can obviously see that from here. This one starts from 1, right, and this one starts from 0. Okay, so the first things first, in order to add or subtract two or more power series, we need to see that after expanding the both of these series, the first terms, their x component, their x powers of the first term is the same. That means if you open this one up, how do we open it? We just put in the variation of n over here. So we just need to see the first term of this series. So if we put n equals to 0 over here, so हमारे पास क्या आता है, c1 x power 0, right? So we have x power 0 over here, and if we open this one up, we just need the first term. तो first term में हमारे पास क्या आ जाएगा, c, यहाँ पे n equals to 0 put करेंगे, तो 6 c naught x power 1. So we are having x power 1 over here. So these powers should match. If they're not same, we have to make it same. How can we make it same? This one is the power is smaller than this one, so we're just gonna skip one term from this series. We're just gonna take the first term of this series out and then combine the other ones, right? So सिर्फ पहली वाली term को बाहर रखेंगे, बाकी सारी as it is रहने देंगे. So पहली term हमारे पास क्या थी, 2c1 and plus the next one will be in the combined formation as it is. अब यहाँ पे n कहाँ से start होगा? It will start from 2 to infinity, because n equals to 1 वाली term हम already we're just letting it out, हम इसको बाहर निकाल चुके हैं. Okay, and same is the case. Okay, अब यहाँ पे अगर इसकी first term अगर आप open करो, so हमारे पास क्या होगा, n equals to 2 put करेंगे तो open होगा ना, तो ये आ जाएगा 2 into 2 4 c2 x power, अब यहाँ पे 1 आ गया. सो दिस इज़ x पावर 1 एंड यहाँ पे भी x पावर 1 थी, तो अब ये वाली दो सीरीज़ जो है मैच कर गई हैं. ओके, इनके x पावर्स जो है मैच कर गए हैं. ओके, सो दिस वन, इस वाली को हम कुछ भी नहीं कहेंगे बिकॉज ये मैच हो चुका हुआ है. सो वी आर डन विद इट. द फर्स्ट स्टेप इज़ डन. फर्स्ट स्टेप क्या था कि आपने फर्स्ट टर्म्स को ओपन करना है, जितनी भी सीरीज़ हैं, और उनके x की पावर्स हैं, उनकी फर्स्ट टर्म्स की x की पावर्स आपने देखनी है मैच हो रही है नहीं हो रही. अगर नहीं हो रही है तो यू हैव टू मैच इट. सो यहाँ पे देयर वी हैव इट, हमारे पास मैच हो गया, राइट? अब नेक्स्ट वी नीड टू सी दैट द समेशन इंडेक्स आल्सो गेट्स मैच्ड, राइट? सो इफ़ यहाँ पे 2 से स्टार्ट हो रहा है, यहाँ पे भी 2 से स्टार्ट होना चाहिए. सो वी हैव टू एज एन एग्जाम्पल आई सेड दैट, सो वी हैव टू मैच दी समेशन इंडेक्सेस. हाउ डू वी डू दैट? वी जस्ट पुट इन द पावर्स. वी जस्ट गोना लेट n minus 1, this is x power n minus 1, so we're just gonna let the power which is n minus 1 equals to some other number which is k, right? And same is the case over here. We're just gonna let n plus 1 is equal to the same number k, right? So सीन क्या होगा? सीन कुछ ऐसा होगा कि हमारे पास ये 2c1 प्लस ये हमारा हो जाएगा. ओके, सो समेशन राइट अब n से हमने k की दुनिया में चले जाना है, सो n को हम इग्नोर, n की जगह हम k की वेरिएशंस को पुट करते जाएंगे. सो इफ़ n इज स्टार्टिंग फ्रॉम 2, सो इफ़ n इज स्टार्टिंग फ्रॉम 2, सो k विल बी स्टार्टिंग फ्रॉम, k कहाँ से स्टार्ट होगा 1 से. सो समेशन k इक्वल्स टू 1 टू इन्फिनिटी. अब हमारा समेशन इंडेक्स क्या है, दिस इज़ k ओवर हेयर, पहले n था, सो 2 एज इट इज़. अब n की जगह हम क्या पुट कर सकते हैं, n की जगह वी आर जस्ट गोना पुट k प्लस 1, और फिर आपका आ जाएगा c, और n की जगह देन अगेन k प्लस 1 एंड x पावर, ओके नीचे जा रहा है थोड़ा सा, इसको हम यहाँ कर देते हैं ताकि आइडेंटिफाई हो जाए. ओके x पावर k, बिकॉज n माइनस 1 को हमने k एज्यूम किया हुआ था, राइट. देन देयर इज़ अ पॉजिटिव साइन एंड देन समेशन. ओके अब यहाँ पे क्या थी n प्लस 1, n प्लस 1 को भी हमने k के इक्वल रखा. एंड इफ़ n इज स्टार्टिंग फ्रॉम 0, सो इफ़ n इज स्टार्टिंग फ्रॉम 0, सो k विल बी स्टार्टिंग फ्रॉम 1. So यहाँ पे summation then again k is starting from 1 to infinity 6 c n. What is n? We are going to see from here n क्या हो जाएगा k minus 1 and x power n plus 1 की क्या वैल्यू हमने suppose की k. So अब आप देख सकते हो कि the summation is the same. This is also starting from 1 and this one is also starting from 1. The summation is also the same and the x powers is also the same, right? The xk term is also the same. So we can take it out and we can write it like this: 2 into k plus 1 into ck plus 1 plus 6 into ck minus 1, and we're just going to take out this term as common, right? So this is how we just add up these two series. Adding means combining these two series. We just wrote the sum of two different series as one series. ठीक है, so this is how addition or subtraction is done. So hopefully थोड़ा concept है वो clear हुआ है. Next we're going to see how to solve a differential equation using if we have power series solution. So okay, take care, Allah Hafiz.